So we're going to talk a little bit about meta-analyses now and why you might want to consider meta-analysis or synthesis before you start your own experiment. So meta-analysis is really just a quantitative way of summarizing the literature. So it's not a review in that there are well-developed statistical techniques that people use to actually quantitatively summarize the results of other experiments or studies, or multiple experiments of your own. It is a research endeavor in and of itself. It takes a lot of time to cull the data and to do the analyses for these, but they can be incredibly useful, especially for policymakers or non-specialists who want to understand the lay of the land or understand what we know in generalities that they can start to glean from the scientific community that might be useful for decision making. Some of the things that are really important to know about meta-analyses is that when you're doing a meta-analysis, it's kind of like trying to compare apples and oranges, and we do a number of things to try to make results as comparable as we possibly can so that it's more like comparing tangerine to oranges than the apples and oranges example that I started with. We will comb through the data to try to increase our sample size and really capture the entire literature or the number of experiments that have been done on a particular subject. So if you want your data included, it's best that you actually make your data accessible. So one way that you can do this is making sure that you put your data in an online data repository when you're done with your research, or make it accessible in a paper. Another thing you might want to consider if you want your data included in meta-analytic efforts is to make sure that your error estimates are very clear. So when we calculate a mean or an effect size for a particular question, what we often do is we weight by the error or the replication in a study. So it's really critical. It seems so simple, but you would be surprised how often it doesn't happen. But it's so critical that you actually report what your error bars are. Are those standard deviation? Is it standard error of the mean? Is it a 95% confidence interval? That needs to go onto every figure in your paper, very clearly in the legend. It's a simple rule, but it would make it so much easier to actually include that data in these synthesis efforts. Another thing you might consider is really clearly explaining your experimental design, and what I mean here is actually the N that you use in your statistical analysis. So when we work on multiple stressors, we often have these really complicated experimental designs with tanks nested in tanks, nested in tanks, but we need that N to actually weight the effect size when we're doing our analyses. So if you can report that in your study, it would be really helpful. In addition, you might want to report where your organisms were collected and the background conditions that those organisms come from. This is going to help us interpret the results or why some results might be quite different from others. And then the last thing you might consider is any way that you can make your treatment values more comparable to others. So for example, in a multi-stressor experiment, you might want to look at the effect of two different factors and a large response surface on organismal performance. If you're looking at global change drivers, you might consider something like the year 2100 as one of your treatment levels or our projections for that year, just so we can compare with other studies that often use those values. So you don't want it to drive your design, but if there's ways to work it into your design so that you can be compared to other studies, it just includes the chances that your work will contribute to really our broader knowledge on the subject, and then hopefully to inform policymakers, decision makers, and other users of the research.